Hi everyone, today I'm going to teach you the basic concept of circular permutation, and I'm going to give you of course illustration and simple problems. So these problems that I'm going to discuss to you are simple problems and they are without any condition. Okay, let me give you an illustration first about circular permutation. So let's consider this problem. John, Ryan, and Brian are about to sit around a circular table. How many different arrangements are possible? So here we can see these are the some possible arrangement that we have. So J stands for John, R is Ryan, and then B is Brian. Now I want you to look at this and try to observe the arrangement that are similar. So there are six different arrangement here, but are those six really different or they are just the same? Or some of them are just the same in one way or another. I'm gonna give you time to think. All right. Now let's consider arrangement number one. So here we have John, Brian, and Brian. And I'm going to emphasize that the arrangement here is clockwise, right? So John is there, obviously, and then Ryan and Brian. Now you go to the second arrangement. Is that similar to the first arrangement? Meaning John, Ryan, and then Brian? All right, no. So here, John, after John is Brian, and then after Brian is Ryan, and then Ryan to John. So these two are different arrangements, right? So let's try the third arrangement. So I want you to look up the J first, and then the R, and then the B. Here, the arrangement, so I'm gonna write here first just to make sure we are following the arrangement. Here, the arrangement is John, Ryan, and Brian. And here it's John, Brian, and Ryan. Okay. Now, if you look at the third arrangement, we can see here if we start with John, after John is Ryan, and then Brian to John, meaning this is technically the same as the first one. John, Ryan, and Brian arrangement in a counterclockwise manner, right? So if you move the chairs or if you start anywhere else, the arrangement is basically the same because this is circular permutation or the table is a circle. So this arrangement 1 and arrangement number 3, they're the same. Okay, how about number 4 or the fourth arrangement? Let's see. Let's start with John and then we got Brian and then Brian to Ryan and then Ryan to John. So basically this is John, Brian, Ryan, and that is the same as the second arrangement. They're identical. How about the fifth arrangement? Let's see. So this is John, okay, this is Brian, and then Brian to John, Brian to Ryan, and then Ryan to John. So JBR, which is the same JBR. So this is the same as the second and the fourth arrangement. Okay, so those arrangement 2, 4, and 5, they are just considered one because technically speaking, they're the same, because of the circular arrangement. How about the sixth one? So we have John, Ryan, Brian, and then Ryan to John. That is the same as John, Ryan, Brian, which is the same as the first and the third arrangement. So here we can clearly see that if we arrange, going back to the problem, how many different arrangements are possible? So technically speaking, the total number of arrangement is just 2. Right? It's just 2. Now, of course, not all problems are required you to, show this kind of illustration. So I'm just giving you an illustration here. There's a shortcut to that, and it's very easy. So in a circular permutation, the number of ways to arrange n distinct objects along a fixed circle is n minus 1 factorial. So n is the number of arrangement or the number of people or objects we have in the problem. So in the previous example or in the illustration, we have there three different persons. So John, Ryan, and Brian. So that's 3 minus 1, which is equal to 2, and 2 factorial is just 2 times 1, which is equal to 2. Right? Okay, let me give you another example. So find the number of ways which 10 beads can be arranged to form a necklace. So we all know that if we form a necklace, it's circular. So the number of objects here is 10. So to compute the number of ways we can arrange this is just 10 minus 1 factorial, which is 9 factorial. 9 factorial means, okay, just so you know, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equivalent to 328,880 different arrangement. I know that's a lot. Okay, let's go to the next one. There are 5 persons. They are named A, B, C, D, and E who are sitting in a circle. Find the total number of different permutations of them. So there's no condition here whatsoever. It just 5 minus 1 factorial, which is 4 factorial. And that means 4 times 3 times 2 times 1, which is equal to 24. All right? And I think that's it. Thank you for watching.